Hello, in this lecture we will find the size of angle x in two different methods. In the drawing we have quadrilateral SRPQ. We know that SP equals to SQ, so we will define SP as y, and then SQ will be also equal to y because they are equal to each other. And we also know that angle PRQ, this angle is equal to 50 degrees, and angle SRP, this angle equals to 65 degrees, and we want to find out the size of angle PSQ, that is defined as angle x. Okay, so we will start with the first method. We will do a construction. Actually, we will extend side RQ of the quadrilateral by a straight line. We will extend side RQ of the quadrilateral by a straight line, and then from point S we will draw perpendicular to the extended QR. So actually this angle equals to 90 degrees. It is a right angle. And we will define the touching point between the perpendicular to the extended QR as point N. Then we will draw from point S perpendicular to PR. So this angle will be equal to 90 degrees. It is a right angle, and this angle will be also equal to 90 degrees, and we will define the touching point between the perpendicular and PR as point M. Then we actually have a rule number one. Rule number one states that the sum of the angles on one side of a straight line, the sum of the angles on one side of a straight line is equal to 180 degrees. I will read the rule again. The rule states that the sum of the angles on one side of a straight line is equal to 180 degrees. So we actually can implement rule number one in our drawing. Here QR is one side of quadrilateral SRPQ, therefore it is a straight line. So actually we extended the straight line QR by a straight line, so QN will remain a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look from the bottom side of the straight line QN at point R, this point, the sum of the angles according to rule number 1 will be equal to 180 degrees. So if we define this angle as angle Z, then we will get that angle Z plus this angle that is 65 degrees plus this angle that is 50 degrees must be equal to 180 degrees according to rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the straight line QN only on this side, then and point R, then the sum of the angles must be equal to 180 degrees. That is to say, angle Z plus 65 degrees plus 50 degrees must be equal to 180 degrees according to rule 1. So here we will subtract from this equality 50 degrees and we will get that angle Z plus 65 degrees equals to 180 degrees minus 50 degrees is 130 degrees. Here we will subtract from this equality 65 degrees and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we actually found out that angle Z equals to 65 degrees. So we will write here that this angle, this is actually angle NRS, equals to 65 degrees. Okay. So in the next step we will prove that those two right triangles can go into each other. Actually, write the green right triangle SRM. We will prove that this green right triangle SRM is congruent to the blue right triangle SNR. Okay, we will prove that those two right triangles can go into each other, or the green triangle is congruent to the right triangle. Okay, so I write it down. We will actually prove that this green right triangle SRM is congruent to triangle SRN. Okay, so we will prove that the green triangle SRM is congruent to the blue triangle SRN. Okay. So first of all, we have here, this point is point R. Okay. We have here side SR, that is a common side. It belongs to both triangles, to the green triangle and to the blue triangle also. So SR equals to SR as a common side that belongs to both triangles. SR is equal to SR as a common side that belongs to both triangles. Okay, SR equals to SR as a common side, and the green triangle has one angle that equals to 90 degrees and the other angle that equals to 65 degrees, and also the blue triangle has the same two angles. One angle is 65 degrees and the other angle is 90 degrees. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay, so if we have one angle that equals to 90 degrees and the other angle that equals to 65 degrees, in total the sum of those two angles is actually 155 degrees. So actually the third angle must be equal to 180 degrees minus 155 degrees in order to complete the sum of the angles to 180 degrees. So 180 degrees minus 155 degrees is 25 degrees. So we actually found out that this angle equals to 25 degrees, and here this angle NSR will be also equal also to 25 degrees because of the fact that we have here also 90 degrees and 65 degrees. The sum of those two angles is also 155 degrees, so the third angle must be equal to 180 degrees minus the sum of those two angles in order to complete the sum of the three angles in the blue triangle to 180 degrees. So we actually found out that those two angles are equal to each other, and so angle SNR and angle NSR in the blue triangle is equal to angle MSR in the green triangle, this angle, and they are both equal to 25 degrees. We have those two angles that are equal to each other, so angle SMR is equal to angle NSR, and both angles are equal to 90 degrees. Angle MSR is equal to angle NSR, and both angles are equal to 90 degrees. And also we have those two angles that are equal to each other. So angle MRS, this angle in the green triangle, angle MRS is equal to angle NRS, and both those two angles are equal to 25 degrees. Okay, so actually we found out that all the three angles of the green triangle are corresponding equal to all the three angles of the blue triangle, and we also have those two common sides that belongs to both triangles. So SR is equal to SR. So we actually proved that the green triangle SRM is congruent. This is the sign of congruent to triangle SRN, according to angle side angle rule. We have actually this side SR and the angle that attach to these sides, the two angles that attach to these two sides, that is to say 25 degrees and 65 degrees, in the green triangle that are correspondingly equal to the same side, and the two angles that are attached to this side SR in the blue triangle. Therefore, those two triangles can go into each other according to side angle side rule. And the side angle side rule states that if you prove that two angles and the side that attach to those two angles in one triangle is correspondingly equal to two angles and the side that attach to those two angles in the other triangle, then you proved that those two triangles can go into each other according to angle side angle rule. Okay, so we proved that those two triangles can go into each other. Therefore, from the fact that those two triangles can go into each other, we can conclude that SM equals to SN. Again, we can conclude that SM is equal to SN according to the rule that corresponding sides and congruent triangles are equal to each other. The green triangles can go into the blue triangle, therefore those two corresponding sides will be equal to each other. That is to say, SM will be equal to SN. Okay? So, in the next step we will focus on the right triangle SMR, right triangle SMP, this right triangle SMP, and the right triangle SNQ. And we will prove that those two right triangles can go into each other. Okay? So we will focus on triangle SMP and triangle SNQ. So I will repeat again, we will actually prove that the right triangle SMP is congruent to the right triangle SNQ. So first of all, we just right now prove that SM equals to SN. So SM of the right triangle SMP is equal to SN of the right triangle SNQ. SM equals to SN. Okay, SM equals to SN, and it is given us in the question that SP is equal to SQ. SP is equal to SQ, it is given us in the question. SP equals to SQ, and both sides are equal to Y. SP equals to SQ, and both sides are equal to Y according to our definition. And in the next step we will prove that PM equals to NQ. So we will have to we'll prove that PM, side PM of triangle SMP is equal to side NQ of triangle, right triangle SNQ. PM equals to NQ. So that is what we need to prove, that PM equals to NQ. We have here two right triangles, therefore we can implement the Pythagorean theorem in those two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, that is to say, if we focus on the right triangle SMP, it means that SM square plus PM square will be equal to SP square. Again, SM square plus PM square must be equal to PS square, that is the hypotenuse square. PS square. So this equality is according to the Pythagorean theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here we will subtract Sm squared from this equality and we will get that Pm squared equals to Ps squared minus Sm squared. Here we will take a root out of this equality and we will get that Pm equals to the root of Ps squared minus Sm squared. We found out the value of Pm equals to the root of Ps squared minus Sm squared. So we will repeat with the same process on the right triangle, triangle SNQ. On this right triangle, triangle SNQ, we know that Sn squared plus nq squared will be equal to sq squared, that is the hypotenuse. Okay, Sn squared plus nq squared will be equal to sq squared. Here we will subtract Sn squared from this equality and we will get that nq squared equals to Sn squared this is a sq squared sq squared minus Sn squared. Here we will take a root out of this equality and we will get that nq equals to the root of sq squared minus Sn squared. So we actually found out the value of nq and we have already found out that Pm is equal to the root of Ps squared minus Sm squared. Okay. Actually, those two expressions are equal to each other. That means that Pm equals to nq. We'll see that those two expressions in the root are equal to each other. So actually, here the root of Ps squared minus Sm squared is equal to the root of sq squared minus Sn squared. Those two expressions are equal to each other, therefore this is actually Pm and this expression is actually nq. That means that Pm equals to nq. Why those two expressions are equal to each other? Because actually Ps is equal to sq according to what is given us in the question. Ps or Sp is equal to sq. Ps or Sp equal to sq, and we have already proved that Sm equals to Sn. We proved that Sm equals to Sn. Okay, so actually we proved that those two expressions are equal to each other. So this expression is actually Pm and this expression is actually NQ. They are equal to each other, so PM is equals to NQ. So we actually proved that all three sides of the right triangle SMP are correspondingly equal on the three sides of triangle SNQ. The right triangle, triangle SNQ. Therefore, we actually proved that triangle SMP is congruent to triangle SNQ according to side rule. Side rule is actually if you prove that all three sides of one triangle are corresponding equal to all the three sides of the other triangle, then you actually prove that those two triangles can go into each other according to side rule. Okay? So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. That is to say, angle SPM is equal to angle SQN, this angle. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will equal to each other. Okay, so if we define angle PQ as theta, then angle SQN will be also equal to theta because of the fact that those two angles are equal to each other. So we actually found that angle SPM is equal to angle SQN and it equals to theta according to our definition. Okay? In the next step I will present to you rule number 2 that we will use in our drawing. So actually rule number 2 states that if a line segment subtends on two equal angles on the same side, if a line segment subtends on two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. I will read rule number 2 again. rule number 2 states that if a line segment subtends on two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So actually you can implement rule number 2 in our drawing, because in our drawing we have those two equal angles, both of them are equal to theta, and those two equal angles, both of them subtend on the same segment line SR. This angle theta is subtend on line segment SR, and this angle theta subtend also on the same line segment SR. Therefore, according to rule number 2, the quadrilateral SRPQ, this quadrilateral inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. So here, this is the implementation of rule number 2 in our drawing. We actually have here the two equal angles theta that subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ, this quadrilateral, is inscribed by the red circle, and the 4 points S, R, P, and Q lie on this red circle. Okay? This is according to rule number 2. And we also have rule number 3. Rule number 3 states that peripheral angles that subtend on the same chord are equal to each other. So I'll read rule number 3 again. Rule number 3 says that peripheral angles that subtend on the same chord are equal to each other. So actually the meaning of rule number 3 is that we have here two peripheral. Actually I didn't write here all the drawing. Here we have actually this angle is angle X, and this angle equals to 50 degrees. Okay, so here we have two peripheral angles, angle X or angle PSQ that equals to X is a peripheral angle that subtend on chord PQ, and we have also angle PSQ that equals to 50 degrees that subtend also on the same chord PQ. Therefore, according to rule number 3, peripheral angles that subtend on the same chord equal to each other. So those two peripheral angles subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, X equals to 50 degrees Okay, x equals to 50 degrees according to rule number 3, because of the fact that those two peripheral angles subtend on the same chord called PQ, they are equal to each other. Okay, so we found out that angle x equals to 50 degrees. Okay, so we finished with the first method. In the next step, I will present to you the second method to find the size of angle x. Actually, in the second method, we do another construction. We will extend side SR by a straight line. Then we will draw, or we will raise a perpendicular from point Q to the extended SR. So this angle is a right angle, it equals to 90 degrees. In the next step, so we will define the touching point between the perpendicular to the extended SR is point M. And then in the next step, we will extend line segment MQ, the perpendicular MQ, in such a way that Q dash M, Q dash M will be equal to QM. Again, I will write it here that Q dash M is equals to QM according to our construction, because of the fact that we extended the perpendicular QM in such a way that Q dash M will be equal to QM. Then we will join together points R and Q dash by a straight line. Okay. We join together points R and Q dash. And we will also join together points S and Q dash. Also by a straight line. So actually SR is one side of quadrilateral SRPQ, therefore it must be a straight line. And then we extended the straight line SR by a straight line, so SM will be still a straight line. So I'll write it down that we know that SM is a straight line. SM is a straight line. And actually we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees according to rule number 1. So if we define this angle as angle Z, then according to rule number 1, the sum of the angles on the bottom side of the straight line SM at point R must be equal to 180 degrees according to rule number 1. That is to say 65 degrees plus 50 degrees plus the size of angle Z must be equal to 180 degrees according to rule number 1 that I mentioned in the first method. Okay, the sum of the angles on the bottom side of the straight line SM must be equal to 180 degrees according to rule number 1. So here we will subtract from this equality 50 degrees and we will get that 65 degrees plus Z equals to 180 degrees minus 50 degrees is 130 degrees. Here we will subtract from this equality 65 degrees and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we actually found out that the size of angle Z is 65 degrees. So we write into drawing that angle Z equals to 65 degrees. And here we know that QM is perpendicular to SM because we raised from point Q perpendicular to the extended SR. So QM is perpendicular, it is a straight line. Then we extended the straight line QM by a straight line. So Q dash Q must be also a straight line because we extended the straight line QM by a straight line. So Q dash Q will be still a straight line. So I write it down that Q dash Q is a straight line and we know that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on this side of the straight line Q dash Q at point M, the sum of the angles must be equal to 180 degrees. So if we define this angle as angle L, then at point M, the sum of the angles on this side of the straight line Q dash Q must be equal to 180 degrees. So which angles we have at point M on this side of the straight line Q dash Q? We have here 90 degrees plus angle L must be equal to 180 degrees, again according to rule number 1. Okay, 90 degrees plus L equals to 180 degrees. Here we will subtract from this equality 90 degrees and we will get that L equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle L is a right angle. Okay, so actually both those two angles at point M are right angles. So in the next step we will prove that those two right angles are equal to each other. Again, the right triangle QMR and the right triangle Q dash MR. This right triangle So I will repeat again what I have said. We will prove that the right triangle QMR is congruent to the right triangle QDSMR. First of all, we know that QM is equal to QDSM according to our construction. We built it like that QM will be equal to QDSM. So QM is equal to QDSM according to our construction. Then we also know that those two angles are equal to each other. Both of those two angles are equal to 90 degrees. So angle QMR is equal to angle QDSMR, and both angles are equal to 90 degrees. Okay, angle QMR is equal to angle QDSMR, and both angles are equal to 90 degrees. And we also have here a common side. M is a common side, or MR is a common side. It belongs to both triangles, so we can write down that MR equals to MR. It's a common side that belongs to both triangles. So MR equals to MR. It is a common side. So we actually proved that triangle QMR is congruent to triangle QDSMR according to side angle side rule. So I write it down that triangle QMR is congruent. Again, this is the sign of congruent to triangle QDSMR according to side angle side rule. We actually proved that those two sides and the angle between them on the right triangle QDSMR are correspondingly equal to those two sides and the angle between them on the right triangle QMR. Therefore, we proved that those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So actually, angle QRM is equal to angle QDSRM. Angle QRM is equal to angle QDSRM, but we know that this angle equals to 65 degrees. Angle QRM equals to 65 degrees. Therefore, this angle will be also equal to 65 degrees because of the fact that those two angles are equal to each other. Okay, so we found out that angle QRM equals to angle QDSRM, and both angles are equal to 65 degrees. Again, according to the rule that corresponding angles in congruent triangles are equal to each other. And we also can conclude that QR is equal to QDSR according to the rule that corresponding sides in congruent triangles are equal to each other. So I'm writing down. We will conclude also that QR is equal to QDSR. I'll repeat again, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be equal to each other. Okay, so in the next step we'll focus on the big right triangle, triangle QMS, and on the big right triangle, triangle QDesMS, and we prove that those two triangles can go into each other. Okay, so I write it down. We'll focus on triangle QMS, this big right triangle, and triangle QDesMS. I will repeat again. We'll prove that the right triangle, right big triangle QMS is congruent to the right big triangle QDesMS. Okay? Those two big right triangles can go into each other. First of all, we know that QM equals to QDesM according to our construction. QM is equal to QDesM according to our construction. Again, QM equals to QDesM according to our construction. And we also know that those two angles are equal to each other and both equal to 90 degrees. So we can write down that angle QMR is angle QMS. Okay, angle QMS is equal to angle QDesMS, and both angles are equal to 90 degrees. Angle QMS is equal to angle QDesMS. Angle QMS is equal to angle QDesMS, and both angles are equal to 90 degrees. And we also have here a common side. SM is a common side, it belongs to both triangles, so SM equals to SM as a common side. SM equals to SM as a common side. Again, SM equals to SM as a common side. So we actually proved that the big right triangle QMS is congruent to the big right triangle QDesMS according to side angle side rule. I will mention the meaning of side angle side rule. Triangle QMS is congruent to triangle QDesMS according to side angle side rule. Okay. Actually, those two sides and the angle between them in triangle QDesMS are corresponding equal to those two sides and the angle between them in the right big triangle, triangle QMS. Therefore, those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we will conclude that those two sides are equal to each other according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides will be equal to each other. That is to say, SQ equals to SQ-des. SQ equals to SQ-des according to the rule that corresponding sides and congruent triangles are equal to each other. And we also know that those two sides are also equal to each other, so if we define side PS as y, then side SQ will be also equal to y, and side SQ equals to side SQ-des, so side SQ-des will be also equal to y. So SQ equals to SQ-des, and both sides are equal to y. So in the next step we will focus on triangle SRQ and on triangle SRQ-, and we will prove that those two triangles can go into each other. Okay, so triangle SRQ and triangle SRQ-. I will repeat again. We will prove that triangle SRQ is congruent to triangle SRQ-. First of all, we know we've already proved that RQ equals to RQ-. RQ equals to RQ-. We have already proved it. RQ equals to RQ-. We just right now proved that SQ equals to SQ-, and both sides are equal to y. SQ equals to SQ-, and both sides are equal to y according to our definition. SQ equals to SQ-, and both sides are equal to y according to our definition. And we have the third side. Side SR is a common side, it belongs to both triangles, so SR is equal to SR. It's a common side that belongs to both triangles. SR equals to SR is a common side, so we actually proved the three sides of triangle SRQ are correspondingly equal to three sides of triangle SRQ-. Therefore, those two triangles can go into each other according to side rule. So I write it down. Triangle SRQ congruent to triangle SRQ-, according to side rule. Side rule says that if you prove that all the sides of one triangle are correspondingly equal to all the sides of the other triangle, then you prove that those two triangles can go into each other according to side rule. So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be equal to each other. So angle SQR is equal to angle SQ-R. Angle SQ-R. Okay? And if we define angle SQR as theta, then angle SQ-R will be also equal to theta because of the fact that those two angles are equal to each other. So SQR is equals to angle SQ-R, and both angles are equal to theta according to our definition. So in the next step we will prove that PQ- is a straight line. Okay, PQ- is a straight line. We will prove that PQ- is a straight line by calculating the size of angle PRQ- from the bottom side, from this side. So the size of angle PRQ- is actually 50 degrees plus 65 degrees plus 65 degrees. We calculated the size of angle PRQ from this side, from the bottom side. Okay, so here 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. So we found out that the size of angle PRQ is 180 degrees. So any angle that equals to 180 degrees is actually a straight line. If angle is equal to 180 degrees, it is actually a straight line. So actually we can conclude that PRQ dash is a straight line. PRQ dash is a straight line. And if PRQ dash is a straight line, then PQ dash will be also a straight line. Okay, PQ dash will be also a straight line. PQ dash is a straight line. So PQ dash is a straight line, and because of the fact that PQ dash is a straight line, then the shape PSQ dash is a triangle. The shape PSQ dash is a triangle. So if we focus on triangle PSQ dash, triangle PSQ dash, in triangle PSQ dash, we know that PS equals to SQ dash is equal to Y. PS equals to SQ dash equal to Y. Okay, again, PS equals to SQ dash equals to Y. And we have the rule that states that in front of equal sides in the triangle there are equal angles. So in front of this side PS we have this angle theta, and in front of this side SQ dash, that is actually Y, we have this angle SPQ dash. So according to the rule that I stated, in front of equal sides there are equal angles. Those two angles are equal to each other. But we know that this angle equals to theta, so this angle must be also equal to theta because of the fact that those two angles are equal to each other. So we found that this angle equals to theta, so from now on we will continue according to method 1. We have here two angles that equal to each other, both of them equal to theta. And those two angles subtend on the same segment line SR. This angle theta subtend on the segment line SR, and this angle theta subtend on the same segment line SR. Therefore, according to rule number 2, the quadrilateral SRPQ, this quadrilateral is inscribed by a circle, and points SR, P, and Q lie on that circle. Okay, so according to rule number 2, because of the fact that those two equal angles subtend on the same segment line SR, therefore this quadrilateral SRPQ is inscribed by this circle, and the 4 points S, R, P, and Q lie on this circle. Okay, and we actually have also rule number 3 that I mentioned in method 1. Rule number 3 states that peripheral angles that subtend on the same chord are equal to each other. We have angle X that subtend on chord PQ, and we have angle PRQ that equals to 50 degrees that subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, X equals to 50 degrees. X equals to 50 degrees according to rule number 3. Because of the fact that those two peripheral angles subtend on the same chord, they are equal to each other. That is to say, X equals to 50 degrees. So we finished with the second method. So in the next step I will summarize the lecture. Actually, we wanted in the first method to find out the size of angle X, and we did a construction. In the first method, we actually extended side QR by a straight line, and then from point S we draw perpendicular to the extended QR, so this angle is 90 degrees. We define the touching point between the extended QR to the perpendicular as point N. So this angle is 90 degrees, and again SNR is 90 degrees. And then from point S we draw perpendicular to PR. So this angle is 90 degrees and this angle is 90 degrees, and we define the touching point between the perpendicular to PR as point M. Then we calculated the size of this angle. QR is one side of quadrilateral SRPQ, therefore it must be a straight line. And then we extended the straight line QR by a straight line, so QN will be still a straight line because we extended the straight line by a straight line. So QN is still a straight line. And we have also rule number 1 that states that the sum of the angles on one side of a triangle is equal to 180 degrees. Okay, the sum of the angles on one side of a triangle is equal to 180 degrees. So if we focus on the straight line NQ on this side, at point R, the sum of the angles must be equal to 180 degrees according to rule number 1. That is to say 50 degrees plus 60 degrees plus this angle that we defined as Z must be equal to 180 degrees according to rule number 1. Okay, then we subtracted 50 degrees from this equality and we got that Z plus 65 degrees equals to 180 degrees minus 50 degrees is 130 degrees. Then we subtracted 65 degrees from this equality and we got that the size of angle Z is 130 degrees minus 65 degrees is 65 degrees. So we found out that this angle equals to 65 degrees. Then we actually proved that the green triangle is congruent to the blue triangle. First of all, we have side SR that is a common side. It belongs both to the green triangle and it also belongs to the blue triangle. So it is a common side, so SR equals to SR is a common side. And we have in the green triangle and also in the blue triangle one angle that equals to 90 degrees, the other angle equals to 65 degrees. In total, the sum of those two angles equals to 155 degrees. 90 degrees plus 65 degrees is 155 degrees. So, and we know that the sum of the angles in any triangle is equals to 180 degrees. So we have two angles that the sum of them is 155 degrees. Therefore, the third angle must be equal to 25 degrees in order to complete the sum of the angles to 180 degrees. So those two angles actually equals to 25 degrees. They are equal to each other, of course. So we actually found that all the angles in the green triangle are corresponding equal to all the angles in the blue triangle, and also we have a common side. SR belongs to both triangles, so we actually proved that the green triangle is congruent to the blue triangle according to angle side angle rule. We have here one side that is a current side, and those two angles that attach to them are equal correspondingly to the blue triangle. Okay, those two angles in the side SR are corresponding equal to those two angles and the side SR. Therefore, those two triangles can go into each other according to angle side angle rule. From the fact that those two triangles can go into each other, we can conclude that SM equals to SN according to the rule that corresponding sides and congruent triangles are equal to each other. Then we focus on the right triangle SMP, and on the right triangle SNQ. And we prove that those two right triangles can go into each other. First of all, we just right now proved that SM equals to SN. Then we also know that SP is equals to SQ according to what is given us in the question. SP equals to SQ, and both of those sides are equal to Y according to our definition. And we proved that PM equals to NQ. Because of the fact that we have two right triangles, we can implement the Pythagorean theorem in the two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in these right triangles, we know that SM square plus PM square equals to SP square. In the right triangle SMP, we know that SM, according to the Pythagorean theorem, SM square plus PM square equals to SP square. We subtracted SM square from this equality, and we got that PM square equals to SP square minus SM square. Then we took a root out of this equality, and we got that PM equals to the root of SP square minus SM square. Then we did the same thing also in the right triangle SNQ. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, SN square plus NQ square equals to SQ square. Again, SN square plus NQ square equals to SQ square. Here we subtracted SN square from this equality, and we got that NQ square equals to SQ square minus SN square. Here we took a root out of this equality, and we got that NQ equals to the root of SQ square minus SN square. And we have already found out that PM equals to the root of PS square minus SM square. Actually, those two expressions are equal to each other. That is to say, PM is equal to NQ. Why those two expressions are equal to each other? Here we have this expression is here, and this expression is here. We can see here that PS is equals to SQ according to what is given us in the question. PS equals to SQ, or SP or PS, it is the same. PS equals to SQ according to what is given us in the question. PS equals to SQ, and we have already proved that SM is equal to SN. SM is equal to SN according to what we have already proved. So we actually proved that this expression is equal to this expression, and this expression is actually PM, and this expression is NQ. That is to say, PM equals to NQ. So we proved that PM equals to NQ. Therefore, we actually proved that three sides of the right triangle SMQ, SMP, this right triangle, are corresponding equal to three sides of the right triangle SNQ. Therefore, we proved that those two triangles can go into each other according to side rule. Okay? Then, from the fact that those two right triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other. Therefore, the corresponding angles, those two corresponding angles, will be equal to each other. And if we define this angle as theta, then this angle will be also equal to theta, because they are equal to each other. And then we have rule number 2. We have here two equal angles, both of them are equal to theta. And both those two angles subtend on the same segment line SR. Therefore, according to rule number 2, that states that if a line segment, here we have line segment SR, subtend two equal angles, this line segment subtend those two equal angles from the same side, then according to rule number 2, the quadrilateral SRPQ is inscribed by a circle, and the 4 points S, R, P, and Q lie on that circle. Okay, again, because of the fact that those two equal angles that equal to theta subtend on the same segment line SR, therefore according to rule number 2, the quadrilateral SRPQ is inscribed by the red circle, and the 4 points SR, P, and Q lie on this red circle. That is the implementation of rule number 2 in our drawing. And we also have rule number 3 that states that peripheral angles that subtend on the same chord are equal to each other. Here we have two peripheral angles. Angle PSQ that equals to X is a peripheral angle that subtends on chord PQ, and angle PRQ that equals to 50 degrees subtend on the same chord PQ. So we have here two peripheral angles that subtend on the same chord PQ. Therefore, according to rule number 3, they are equal to each other. That is to say, angle X equals to 50 degrees, according to rule number 3. Okay? Then we actually so we finished with the first method, and we found out the size of angle X according to a second method. In the second method, we actually extended side SR of the quadrilateral SRPQ. We extended side SR by a straight line, and then from point Q we raised perpendicular to the extended SR, so this angle is 90 degrees, and we defined the touching point between the perpendicular to the extended SR as point M, and then we actually extended the perpendicular QM in such a way that Q dash M is equal to QM. This is according to our construction. Q dash M equals to QM. Okay? So here we calculated the size of this angle according to rule number 1. Actually, SR is one side of quadrilateral SRPQ, therefore it must be a straight line. And we extended the straight line SR by a straight line, so SM will be still a straight line. And we have rule number 1 that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees according to rule number 1. That is to say 65 degrees plus 50 degrees plus the size of this angle that we defined as angle Z must be equal to 180 degrees according to rule number 1. 65 degrees plus 50 degrees plus the size of angle Z equals to 180 degrees according to rule number 1. Here we subtracted 50 degrees from this equality, and we got that 65 degrees plus Z equals to 130 degrees. Here we subtracted 65 degrees from this equality, and we got that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out actually that this angle equals to 65 degrees. Then we use the same rule in order to calculate the size of this angle. Actually, QM is perpendicular. So QM is perpendicular, it must be a straight line. Then we actually extended the straight line QM by a straight line. So Q dash Q must be also a straight line. It still will be a straight line because we extended the straight line QM by a straight line. So Q dash Q is also a straight line. And we have rule number 1 that states that the sum of the angles on one side of the straight line is equal to 180 degrees. So if you look from this side of the straight line Q dash Q, the sum of the angles at point M must be equal to 180 degrees from this side of the straight line Q dash Q. That is to say 90 degrees plus the size of this angle that we defined as angle L must be equal to 180 degrees. According to rule number 1, 90 degrees plus the size of this angle that is defined as angle L must be equal to 180 degrees. According to rule number 1, we subtracted 90 degrees from this equality and we got that the size of angle L is equal to 90 degrees. This angle is a right angle, it equals to 90 degrees, so we actually have here at point M two right angles. Then we actually proved that those two triangles can go into each other. Triangle QMR, the right triangle QMR is congruent to the right triangle Q dash MR. Why? Because we have, first of all, side QM that equals to side Q dash M according to our construction. QM equals to Q dash M according to our construction. Then we have those two angles that are equal to each other, they are both equal to 90 degrees. Angle QMR equals to angle Q dash MR equals to 90 degrees. And we have here a common side. MR is a common side, it belongs to both triangles, so MR equals to MR, it is a common side, it belongs to both triangles. So we actually proved that triangle QMR can go into triangle Q dash MR according to side angle side rule. What is side angle side rule? If we have here two sides and the angle between them that are corresponding equal to two sides and the angle between them on the right triangle QMR, then those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, first of all we can conclude that those two angles are equal to each other. So if this angle is 65 degrees, then this angle will be also equal to 65 degrees. Angle QMR, QM equals to angle Q dash RM equals to 65 degrees. And we will also conclude that QR equals to Q dash R. According to the rule that corresponding sides and congruent triangles are equal to each other. QR equals to Q dash R. Then we focus on the right big triangles, triangle QMS and triangle Q dash MS. And we proved actually that those two right big triangles can go into each other. First of all, we know that QM equals to Q dash M according to our construction. QM equals to Q dash M according to our construction. We also know that those two angles are equal to each other, they are both equal to 90 degrees. So angle QMS equals to angle Q dash MS and they are both equal to 90 degrees. And we have here a common side, SM belongs to both triangles, so SM equals to SM is a common side. So we actually proved that those two triangles, the big right triangle QMS and the big right triangle Q dash MS can go into each other according to side angle side rule. We have here those two sides and the angle between them in triangle Q dash MS that correspond equal to those two sides and the angle between them in triangle QMS. Therefore, those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we can conclude that QS equals to Q dash S, and we find the PS as Y, therefore QS that equals to PS will be also equal to Y, and QS that equals to Q dash S will be also equal to Y. That is according to our definition. Okay, and then we focused on the right triangle SRQ and on the right triangle SRQ dash, and we proved that those two triangles, we actually focused on triangle SRQ and on triangle SRQ dash, and we proved that those two triangles can go into each other. First of all, we know that we've already proved that RQ equals to RQ dash. Then we have already proved that SQ equals to SQ dash. And we have also a common side. SR belongs to both triangles, so SR equals to SR as a common side. So we actually proved that those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. So if one angle is equal to theta, then the other angle must be equal to theta because of the fact that those two angles are equal to each other. Then in the next step, we actually proved that line segment PQ dash is a straight line. How we proved that line segment PQ dash is a straight line? We proved that angle PRQ dash equals to 180 degrees. If we look from the bottom side, from this side of angle PRQ dash, it equals to 180 degrees. So what is the size of angle PRQ dash? It is actually 50 degrees plus 65 degrees plus 65 degrees. That is actually 180 degrees because of the fact that angle PRQ dash equals to 180 degrees. Actually, line segment PRQ dash is a straight line, and if line segment PRQ dash is a straight line, then PQ dash is also a straight line. So we proved that PQ dash is a straight line. From the fact that PQ dash is a straight line, we can conclude that PSQ dash is a triangle, and in triangle PSQ dash we have two sides that are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located between in front of equal sides, those two equal sides, they are also equal to each other, and we know that this angle equals to theta, so this angle must be also equal to theta. So we have here two angles that are equal to each other that subtend on the same segment line SR. Therefore, according to rule number 2 that I mentioned in method 1, actually the quadrilateral SRPQ is inscribed by a circle, and points SRPQ lie on that circle. Okay, quadrilateral SRPQ is inscribed by this circle, and points SRPQ lie on this circle. This is the implementation of rule number 2 in our drawing. And we have also rule number 3 that states that peripheral angles that subtend on the same chord are equal to each other. We have here two peripheral angles. Angle X is the peripheral angle that subtend on chord PQ, and angle PRQ that equals to 50 degrees subtend on the same chord PQ. Therefore, they are equal to each other. That is to say, X equals to 50 degrees according to rule number 3. So we actually proved that angle X equals to 50 degrees according to rule number 3 because of the fact that we have here two peripheral angles. Angle X is the peripheral angle that subtend on chord PQ, and angle PRQ that equals to 50 degrees subtend on the same chord PQ. Therefore, they are equal to each other according to rule number 3. That is to say, angle X equals to 50 degrees. Okay, so we actually proved in both methods that we found out that angle X equals to 50 degrees. Okay, angle X here, that is actually angle PSQ, that is defined as angle X, is equal to 50 degrees. Okay, thank you very much.